We are now looking at complex number tutorial 9b question 2. Question 2 gives us a complex number z equals to 13 minus 5i over 4 minus 9i. And the question first asks us to find the modulus and the argument of complex number z. As you can see, complex number z is rather complicated. So therefore, finding the modulus and the argument of it would be quite difficult if we do not attempt to simplify this complex number. So one of the ways that we can simplify this complex number z is to multiply the numerator and the denominator by the conjugate of 4 minus 9i, which is 4 plus 9i. So we multiply 4 plus 9i at the numerator and the denominator, and then we will simplify it, and we get 1 plus I, which looks much simpler to us. Another way that you can go about simplifying your z is by trying to use your GC to key in this complex number and see whether the calculator can simplify it into something. If the calculator manages to do that, then we can easily just take 1 plus I as the equivalent form of z, and we will continue on to find first the modulus of z, which is to apply the Pythagoras theorem. So in this case, the modulus of z is equals to square root 2. As of the argument of z, for those students who need some visual interpretation, you can construct a very simple Argand diagram. Locate the complex number 1 plus I, and you can easily see that in this case, this particular angle is actually 45 degrees or pi over 4 radian, and that is the argument of z. So now if we were to answer part 1, express z to the power 6 in the form of a plus bi. So this question has two things for you to take note. Number one, the power of the z has been raised to power of 6. So this probably reminds you of using the De Moivre's theorem. Okay, because the question previously has asked you to find modulus and argument. So definitely we will have to make use of these two aspects to help us to find what z power of 6 is. So before we can do that, we shall first express our z in the trigo or polar form. So z equals to square root 2 as our r, cosine pi over 4 plus I sine pi over 4. And now by applying our De Moivre's theorem, z to the power of 6 is equals to square root 2 to the power of 6 cosine of 6 pi over 4 plus I sine of 6 pi over 4. Question wants us to leave in the form of a plus bi, which is the Cartesian form. So therefore, we will need to perform evaluations of all these special values. And you can use your calculator to help you with this. Square root 2 to the power of 6 is actually 8. Cosine of 6 pi over 4 is 0. Sine of 6 pi over 4 is negative 1. So z to the power of 6 is equals to negative 8i. Part 2. The question asks us to solve e to the power of x plus iy equals to 13 minus 5i over 4 minus 9i to the power of 6. In this case, it is clear to us that the right hand side of this equation is exactly our z to the power of 6, and from our previous part we have found out that it is equals to negative 8i. So in this case, the equation has simplified itself into becoming e to the power of x plus iy equals to a negative 8i. If you study these equations carefully, you can apply laws of indices to break up the power to become e to the power x multiplied by e to the power of iy. And it equals to a negative 8i. Now, it is clear to us that because x is a real value, therefore e to the power of x can never be a negative value. It has to be something positive. So, to actually compare the terms on the left and on the right, we should now say that e to the power x times e to the power I should compare with 8 multiplied with a negative I. So the relationship in this case that we are seeing here is e to the power x shall equate to our 8 and e to the power iy shall equate to our negative I. So with that, we are able now to solve for our value of x and our value of y. So we can see that e to the power x equals to 8. So therefore x is equals to ln 8, which you can simplify it to become 3 ln 2. When e to the power of iy is equals to a negative I, again you can try to observe this from your Argand diagram. That negative I is somewhere here. And this tells us very clearly that the argument of this complex number, the angle is turned in a clockwise direction with a magnitude of pi over 2. So therefore, we can then conclude y is equals to negative pi over 2. And this y value is one of the possible values that we can get. And this concludes our question 2.